I am part of research and development in Defense Logistics Agency. My work ties to digital engineering and manufacturing technologies, which ties the Office of Secretary of Defense in the ManTech organization.
Unlike most of DLA that are focused on the day-to-day business, DLA R&D is designed to look ahead. What do we need to do as an agency to prepare for the future? What technology can we bring that helps adapt? Solve a problem or take advantage of a technological advance that helps us do our business better?
My program is called DLA. It stands for Defense Logistics Information Research. As it says, it's information, it's research. We are in the fourth industrial revolution that talks to data era or the digital era. The supply chain is very critical to DLA, and bringing digital in the forefront, we are able to bring new suppliers, new capabilities.
We've been involved with them for over a decade, focused on preparing DLA for what's now called the model-based enterprise. It's using 3D data and associated metadata to solicit and produce the parts that need to support the warfighter.
Digital engineering involves three areas. One is, if you think about it, we need to stay with our military services. Who owns the weapon systems? So how DLA interfaces with it? The second area of digital transformation happens within DLA. How do we manage this data? How the interoperability works between the military services, DLA, and our contractors. The third area is that as we move the data, as you are aware, the cybersecurity, intellectual property protection, all those things need to be taken into consideration.
DLA manages 6 million parts, buys about 500,000 different parts a year, 2 million active parts. Those numbers are plus or minus, but lots of things.
We deal with a lot of small and mid-sized suppliers, and they don't have the IT infrastructure, the information technology infrastructure that we have or the military services have. So we have a project to see what we can do to bring information technology to the Industry 4.0 or fourth industrial revolution.
We want to design that part once and reuse it. When we've got that blueprint, that 2D data, every time we want to go use it on a modern manufacturing machine, somebody has to input the data into a computer to build a model, build the dimensions, build the tolerances into it. And oh, by the way, that's labor hours. Labor hours are dollars. That's time. It means it takes longer to build, longer to buy, longer for somebody to bid a part, all of which means if we're in a back order situation, the warfighter doesn't get his or her part as quickly, and the price is higher because we're doing non-recurring engineering, and we connect all those enterprises together so that we don't have a ESA, engineering support activity in the military service, who controls the design of the part, having one version. DLA having another version, which may or may not map to the first one, and that supplier creating their own version, which should be the same, but may not be. When we talk about the model-based enterprise, it's really about computer talking to computer, talking to computer, with people able to enter the loop. But it's not people are the mechanism that takes from one computer to another computer to a third.
We are going Army, Air Force, we are going in the future, we are going to go to Navy. So we get all the three services and connect our small and mid suppliers so they understand what DLA is doing, and so we can build the digital connection all the way.
So probably the first successful program was the A-10 rewinging, where they did all three data. The CH-53K is using 3D data. So it's happening now, but it's happening because new weapon systems or modifications or upgrades are happening in 3D.
We think of a warfighter always, what we need to do, we bring innovation, we bring speed, better quality, and lower cost. Moving into digital gives all those things.